Hello, students in grade 7. I will be now sending you the mathematics video of lecture 2 in semester 2. And the title of our lesson, as you can see, this is totally a new lesson in grade 7. That's why this lesson is very important. I want you to watch the video more than once. It's not a hard lesson at all. When you get used to this lesson, it will be a very simple and easy lesson. Don't panic. The title of our lesson is Congruent Triangles. Again, congruent triangles. As you can see, I have written number 1. Why? Because we have another lesson named Congruent Triangles after this lesson. But each lesson will teach you something different. But they are very, very similar. They are solved in the same way. You can say this. So the title of our lesson is Congruent Triangles. Objectives. Objective number 1, we will define congruent triangles because this word is new. We are going to define congruent triangles. We will learn what do we mean by congruent triangles. Objective number 2, we will apply in this lesson the first case of congruent triangles, which is called ASA. What does this mean? Two triangles are congruent by angle, side angle. So the first A refers to angle, S refers to side, the second A refers to angle. So ASA means angle, side angle. How can we prove that two triangles are congruent by angle, side angle? If a side and its adjacent angles in the first triangle are equal to a side and its adjacent angles in the second triangle, then we say that these two triangles are congruent by ASA. So in this lesson, we are going to learn only one case of congruency in triangles, which is, don't forget, ASA or angle, side angle. First, let's define congruent triangles. The word congruent means equal triangles. So here we will be dealing with equal triangles. And now I will tell you what do we mean by equal triangles. Two triangles are said to be congruent if their three sides and their three angles are equal. Suppose I have this triangle, which is in purple, and this green triangle. We have seen in the lesson before that in any triangle, we have three sides. This is side 1, this is side 2, this is side 3. In the second triangle, we have this is side 1, this is side 2, this is side 3. We have three angles, angle 1, angle 2, angle 3, angle 1, angle 2, and angle 3. Now we can see that the first triangle is congruent with the second triangle. Why? Because the first side is 5 centimeters in the first triangle, and the first side is 5 centimeters in the second triangle. The second side here in the first triangle is 9 centimeters. In the second triangle, the second side is 9 centimeters also. In the first triangle, the third side is 7 centimeters. In the second triangle, the third side is also 7 centimeters. So the three sides in the first triangle are equal to the three sides in the second triangle. Let me continue. This angle here measures 60 degrees. Also, this angle here between the 5 centimeter and the 9 centimeter measures 60 degrees. The angle between the 5 centimeter and the 7 centimeter is 85 degrees. Also here it is 85 degrees. Also this angle here is 35 degrees and this angle is 35 degrees. So I now can say these two triangles are congruent since they have their three sides and their three angles are equal to each other's. Congruent triangles do not have to be in the same orientation or position. They only have to be identical in size and shape. What do we mean by this? We can have a triangle upwards and another triangle downwards, but both of them are congruent to each other's. This is also 5, this is 5. This is 9, this is 9, this is 7, this is 7. Also the angles are equal, then these two triangles are congruent to each other's. So in congruency of triangles, we might have a triangle oriented upwards, another triangle oriented downwards. They shouldn't have been in the same orientation or position as I said here. Now, never forget this important thing I'm saying now. Two triangles are congruent if one can be placed on top of the other for a perfect match. What does this mean? If I put a triangle ACB above the triangle XYZ, they will look for me in a perfect match that I will be seeing as if one triangle. So if I put two congruent triangles above each other's, they will seem to me as if they are only one triangle. Also here, if I put the triangle EDF above the triangle IHG, if I put them above each other's, I will be seeing only one triangle. They will look for me as if I'm looking at one triangle only. So till now, I have been discussing what do we mean by congruent triangles or equal triangles. Again, equal triangles or congruent triangles have three equal sides and three equal angles. Now, how can we prove or show that two triangles are congruent to each other's? Now, the very important part of our lesson starts. To prove congruent triangles during grade 7, we will be having 3 cases during this year. But in our lesson today, we will be only studying case number 1, congruent triangles case number 1, which is angle side angle. We will be proving congruent triangles by angle side angle, which we abbreviated by ASA. So what does this case say? Let me read this one for you. Angle side angle means two triangles are congruent by angle side angle if a side and its adjacent angles in the first triangle are equal to a side and its adjacent angles in another triangle. So this case is called ASA. Let me now talk about the side and its adjacent angles. If I have two triangles ABC and XYZ, and I wanted to prove that these two triangles are congruent by ASA. As you can see here in this lesson, marking the figure is very important. What do these marks mean for me? If I look at side AB, I can see one mark. If I look at side XY, I can see the same mark. So directly I will say side AB is equal to side XY. So I found the side. Now I need two angles. These two angles should be adjacent to the equal side. Let me look at side AB. How many angles do we have on side AB? We have an angle at vertex A, which is CAB, another angle at vertex B, which is CBA. So these are the adjacent angles to side AB. The adjacent angles to side XY are ZXY and ZYX. As you can see from the marks given, angle CBA is equal to ZYX because here we have this mark, here we have the same mark. So these two angles mean they are equal. Here I have CAB having two marks in it. ZXY has two marks in it. Then these two angles will be equal to each other's. In this case, since I found side, angle, side, angle equal to each other's in two different triangles, these two triangles are congruent by angle, side, angle, or ASA. So please always keep in mind, if you want to prove two congruent triangles by angle, side, angle, first we should look in the first triangle and the second triangle for two equal sides. After we're done with the sides, we now look for two different angles in the two triangles. This is how we prove ASA. Again, what do we mean by side and its adjacent angles? As I discussed here, for example, side XY has two adjacent angles. On any side, we have two adjacent angles. ZXY, ZYX are the adjacent angles. Now, this slide is our lesson. This slide shows you the way that you should write your proof when you prove congruent triangles. So this is a very important notice here, guys. To prove two congruent triangles, there is always a specific way of writing. Do you see these 4 points? You always write congruent triangles. When proving congruent triangles, you should write these 4 steps. Step number 1, we should write a starting sentence. What do we mean by starting sentence? Naming the two triangles to be proved congruent. Step number 2, we should write the elements given to be used in our proof. As I said, first we should look for equal sides in both triangles. Then we look for equal angles that should be adjacent to the equal sides. After we finish, after we find the sides, the angles, step number 3, we should write an ending sentence. So we have a starting sentence, we have a proof, the elements in our proof. We have an ending sentence saying that the two triangles are congruent. This is the conclusion of our proof. After we finish, Step number 4, we should list the homologous elements or the corresponding parts or the equal parts in both triangles. Now, I will apply directly with you a question following each step alone. Let's practice. Prove that the two triangles A, B, C, and E, F, D are congruent. Can you see the marks we have in the first triangle and the marks we have in the second triangle? These marks make our proof very easy. When you mark your figure, guys, the proof will be very easy. You will know where to look in your figure. First, as I said, we should write a starting sentence. The starting sentence is very simple. So, starting sentence, I bring it from the question I'm asked. We say always in triangles, A, B, C, I bring it from the question, and E, F, D, we have. So we should always start with such a starting sentence. Number 2, the elements given. As I said here, the elements given to be used in our proof. First, we should look for the equal sides. Which two sides do you see equal in these two triangles? Which two sides are marked in the same mark? I can see AC and FD. So I write AC is equal to FD. From where did I bring it? From the figure. It is given to me in the question, so I should write from given. Now, on the side AC, this is the adjacent angle and this is the adjacent angle. On the side FD, this is the adjacent angle and this is the adjacent angle. So we have angle BAC marked as EDF. Then they are equal. I write angle BAC is equal to EDF. Also, I brought it from given, from the figure, so I write by given. Now, angle BCA is marked as angle EFD. So these two angles are equal to each other. I write them from the figure, so I write by given. Everything I bring from the figure, I write by given. As you can see here are the elements. We have the sides, we have the angles here. Now, number 3, I should write an ending point. Always I end the two triangles, ABC and EFD are congruent by ASA, because I used angle sides angle. Now, step number 4, I should write or list the homologous elements. The homologous elements mean, as you still remember what I said in the definition of congruent triangles, the three angles in the first triangle, after being congruent with the second, the three angles in the first triangle will be equal to the three angles in the second triangle. This and this are equal by given, so I don't use them in homologous elements. This angle and this angle are equal by given, so I don't use them in homologous elements. This angle and this angle, angle ABC and angle DEF, will be equal to each other. This is the first homologous element. By given, I have AC equal to FD side. This is by given, so I don't write it in homologous elements. I will write side EF will be equal to side BC, side FD will be equal to side AB. So in homologous elements, in the case of ASA, we will be having an angle and two sides. Another example, given this figure in front of you, I can see two triangles, a pink triangle and a blue triangle. The pink triangle is ABC, the blue triangle is A prime. So this we read it A prime BC. We should prove that the two triangles ABC and A prime BC are congruent. Let us follow the steps of writing. First, we should write the beginning sentence or the starting sentence. So we say in triangles ABC, A prime BC, we have. Now we should list the elements. We can see that there are no marks on the sides, but we can see that between the first triangle ABC, the second triangle A prime BC, we have a common side. We have a side BC, which is in the first triangle and in the second triangle. So BC is a common side. This is what I need. So either we use equal sides or common sides. The adjacent angle ABC is equal to the adjacent angle A prime BC. I write it by given because I brought it from the figure. The adjacent angle ACB in the first triangle is equal to the adjacent angle A prime CB in the second triangle, also by given. Now the ending sentence, the two triangles ABC and A prime BC are congruent by ASA. Let's write the homologous elements. First, we still have an angle in the first triangle, another angle in the second triangle. The first homologous element will be angle BAC or CAB will be equal to angle CA prime B. I have written the first homologous element here. Side AB will be equal to side A prime B. Side AC will be equal to side A prime C. Now, I want to remind you of one of the constructions of triangles that we studied together. How can we construct a triangle knowing the measure of one side and two angles? Again, we have steps. Here, to draw such a triangle, we use a long ruler and a protractor. What are the steps? First, we draw the given side. We have only one side, so we draw it using a long ruler. Then we assign the first angle on the given vertex using the protractor. We assign the second angle on the given vertex using the protractor, where these two lines, after joining the assigned angle with the vertex, we get two intersecting lines. Where the two lines intersect gives me the third vertex, as we did here. So here we draw this side, then we assign a 45 degrees angle, we assign a 65 degrees angle, we draw a line where we assign the angles, we get the third vertex, we simply join it with the first and the second, we get the triangle. Here, I have discussed this before, but I'm reminding you how we construct a triangle knowing the measure of one side and two angles. So thank you, my dear students. This was our second lesson in semester 2, the Congruent Triangles 1. Please watch the video well, understand the lesson, and try to practice all exercises you have in this lesson. Thank you very much.